you recording me?
Yeah.
In a data table, the number of dogs plus cats registered living in a rescue shelter in the U.S. was compared. Make a polynomial using the data. Identify the constant term. Profit equals 80% times revenue minus 100. The formula we're going to use is P of X equals 0.8 times F of X minus 100. And then from that we get equals 0.8, and then we plug in the 5x minus 100, and then 0.8 times 5x equals 4x minus 100, and then we plug in the 200, which equals 4 times 200 by plugging the x in, minus 100, and that equals 700. Thrown at 5 feet. Name the vertex, focus, plus directrix. How much are the focus plus directrix affected?
On the graph. So for A, the vertex is always the point in the middle. It's always the center of a line for any kind of graph. So like even if you have a line graph, or it's usually for the quadratic graphs. So when you have a parabola, like here, it's not really shown clearly, of course, because it's not drawn to scale, but for this one, this would be the vertex because this is the center. This is the origin of the parabola. So whatever the origin is, that is the vertex. So this one would be point B. Pretty easy, self-explanatory. So now we have to find the focus, and the focus is this right here. So whatever the vertex is, whatever the point is, right directly in front of the vertex, yeah. So that's the focus right here. So that would be point C. And because there is no other point left and it's right directly behind the vertex, that is the directrix. And excuse me for the bad handwriting. It's just easier for me this way. Be point A. Pretty easy, really self-explanatory. You just have to look at the chart and know what you're looking at. So B is it's a little more steps probably, but it's really easy too. So you're trying to find out how the effect of an underhand throw of a baseball at 4 feet will affect the focus and the directrix. So if you look at your graph, you'll see that it's actually at 5 feet up because of the initial height. So if the baseball was to be thrown underhand at 4 feet, which is right here, and then this is -4, because it would be thrown at 4 feet instead of 5, it will only move the directrix and the focus down 1 unit. So pretty easy. So instead of 4, so what's 5 minus 4 equals 1. So that translates into 1 unit.
The
Grand Canyon is made up around cliffs. The height of one of the cliffs is about 200 feet.
Two parts, both A and B. A is representing how long it will fall before it hits the water, and B is how many feet it will fall between 2 to 3 seconds. So for the first part, for A, we already know the initial height, which is 200 feet, and we already have our formula that we're going to be using that includes the initial height at the end. So with this, it's really quite simple. You just have to, instead of h of t, we're gonna put 0 and then plug in the rest of it. Now we have to cancel out this so that we can be able to divide 200 by this. So we're going to subtract by both sides. and you end up with negative 200. Bring this down, and there you go. So now you're going to divide by both sides, and you always divide one number by another one, but it's important for when you're doing a proportion form that you always divide the one with the variable. So in this case, it'd be negative 16, and that cancels out. Bring it over to the other side, and negative 200 divided by negative 16 is going to give you approximately, 12.5. And 12.5 is your t. Now, that's pretty simple for part A. Now for part B, because we have to figure out how many feet it will fall between 2 to 3 seconds, we use h of 2 and h of 3. Now the h represents the height, and the numbers here represent the seconds that we're going to be estimating between. So you're going to be using the same one that you used here. This initial, this one. And instead of the t that was originally given to us, we're going to fill in with the 2 plus the 200. There we go. And you're also going to do it for the 3. Also, I'm sorry for the bad handwriting. It's kind of hard to hold the camera at the same time. Now, you get 136 for when you plug in the 2 and 56 when you plug in the 3. Now, all you have to do is take these two numbers and subtract them, and what you're going to get is 80. So that 80 is actually 80 feet that it will fall between 2 to 3 seconds. 2 to 3 seconds, I'm sorry. And that's it for the rest of the problem. It said 20.1 t squared plus 410.5 t, can't forget that t, plus 6,593.7. Alright, that's for D. And now for C, it's 18t squared plus 286t plus, 127, 101.4. Okay, now that you have the numbers and the data already for you, now what you're going to do is you're going to put this into parentheses. There we go. And just add it. So you're going to add these together. So a better way to break it up is, if you don't have to, but you can just write it all down if you want again. 10.5t plus, since I don't have enough room over here, I'm just going to do it on this side. Okay, now that you have written down everything, it's just going to be easier to break it up this way. So after you do that, what you're going to want to do is, since these are both the same, 20 plus 20.1t squared, plus 18t squared is 38.1t squared. And then next this one. And whenever you're adding anything like that, you always take the sign in front of the number. So this 410 would be positive because there's a positive in front. Same thing, just basic rules that apply. plus whatever 410.5 plus 286t is. So that's 600, oh, my mistake, 696.5t plus, then again signs, 1, 3, 6, 9, 5.1. Okay, there we go. Which is equal to 0.7. So that is what this equals to. And now to find the constant term, all we're gonna have to do is we take this number and we subtract it by this one as well, okay? So 127.101.4, and that this right here is equal to this one. So it's gonna be brought down over here, 7. Now, if you hit the equal sign on your computer once again, the constant term is equal to 0. They expect the beds to last up to 5 years, at which time its value will have discounted to $2,000.
$10,000. The formula we're going to use is R equals 1 minus, in parentheses, salvage value over original cost, and then 1 divided by the years of expectancy. So to begin, we're going to do R equals 1 minus S over C, 1 divided by N, to divide it to be more professional, equals 1 minus, to plug in salvage value, which is 2,000, over the original cost, which is 10,000. And then over here, 1 divided by 5, the years of expectancy, which equals 1 minus 1 over 5. Because we divide 2,000 by 2,000, which equals 1, and 10,000 by 2,000, which equals 5. And then we have the 1/5 over here also. And then we're going to put that into our calculator. 1 minus 1 divided by 5, the square root, also 1 divided by 5, which gives us 0.275, which is the annual depreciation rate that the orphanage used.
The alien population was about 10.01 billion. During the next 12 years, the alien population increased by about 1.2% each year. For number 1, write an exponential growth model giving the population y in billions plus years after 2008.
0, 1, 2. So the exponential growth model is y equals a in parentheses 1 plus r to the power of t. To find t, we do 2012 minus 2008, which equals 4. And then we plug into the equation right here, and we get 10.01 in parentheses 1.012 to the power of 4. And in the calculator, we put 10.01 in parentheses 1.012 to the power of 4. And we get 10.49.
Por amarte así, a un paso de tu boca.